Hi gang, Eric here. In this video I'm going to show you how to balance chemical equations. This will be part one. There are equations that are easy to balance and equations that are easier to balance. We're going to start with those. So, first question you probably have is why? Why bother? Well, there's something called the law of conservation of matter, which states that matter can neither be created nor destroyed. These days, actually for the last century or so, we've had to add this little extra disclaimer and say, in a normal chemical equation. Why? A fellow by the name of Einstein. He showed that matter and energy can go back and forth between each other. Matter can turn into energy and vice versa. But we completely, utterly ignore that. So, for us, all we have to pay attention to are atoms. How do we do this? Well, we have a chemical equation, and we're going to count the number of atoms we have on both sides. Then we can adjust the number of molecules. Now that, of course, will change the number of atoms, so we have to go back and repeat this process. And we're just going to keep going through this until both sides of the equation have the same number of atoms of all elements. I'm going to switch over to the notebook, and I'll show you how it's done. Okay, here I've got a pretty simple chemical equation. I have methane plus oxygen gas react to form carbon dioxide plus water. If your house is heated by natural gas, this is the reaction that happens inside of your furnace. So in order to see what's going on, let's actually draw out the molecules. Okay, and here you can see the atoms inside the molecule, or my drawing of the atoms inside the molecule. We have 4 hydrogens around 1 carbon. In methane, oxygen is 2 oxygen atoms in the molecule. Then we have carbon dioxide, 1 carbon, 2 oxygens, and then water. Now, if this is the first time you've seen this, don't worry about this. This is just another way to represent. This here means this here, okay? All right, so do you see the problem yet? Well, let's count up. How many carbons do we have on the left side? 1. On the right side, 1. All right, oh, no problem there. Hydrogens on the left, 4. Oh, there's only 2 hydrogens on the right. What happened to the extra 2 hydrogens? They can't just go out and get a cup of coffee, so we're going to have to deal with that. All right, let's keep going. The oxygens. Well, we've got 2 oxygens here. Oh, but on the right, I've got 1, 2, 3. Where'd this guy come from? So we can't have that happen. We can't just magically create or destroy atoms in a basic chemical equation. So what we're going to have to do is change the number of molecules, and that will eventually get us to balance the equation. So let's take a look at the hydrogens first. Here I've got 4 hydrogens. Here I've got 2 hydrogens. So if I add another water molecule, now I have 4 hydrogens and 4 hydrogens. That's great. My oxygens aren't right though. 1, 2, 1, 2, 3, 4. Oh, there's a simple solution. If I just have 2 of those molecules, now I've got 4 atoms of oxygen and 4 atoms of oxygen. This is a balanced chemical equation in picture form. What we have to do is we have to add in coefficients up here in the equation that tell us, oh, here's what the recipe is. 1 molecule of methane plus 2 molecules of oxygen will produce 1 molecule of CO2 plus 2 molecules of water. Now, you don't have to draw this out every time. This obviously takes too much time. So let me show you how I would do this without drawing it. Okay, now I've got the equation rewritten. And you can see what I've done here is I have added underneath the equation some worksheet area for me, where now what I'm going to do is I'm going to count up the atoms. So instead of drawing it out, let's count it out. So 1 carbon, 1 carbon, 4 hydrogens, 2 hydrogens, 2 oxygens, 1, 2, 3 oxygens. So now, if you've got colored pens, this actually I find gets really helpful. So when I make a change up here, it's going to make changes down here. We have to take that into account. So if I put my 2 there, that changes the hydrogens to 4, but it also changes the oxygens to a total of 4. 2 plus 2 times 1, that gives me. So remember what we did? We put the 2 over here, because that changes the oxygens to 4. Let me show you another one. Okay, now I've got my next equation here, and this time we've got propane plus oxygen reacts to form carbon dioxide plus water. This is what happens if you have a propane grill. So let's make the chart. How do I make the chart again? I just literally read across here, C, H, and O, make that down here, and then I mirror it exactly over here on the right-hand side. So I don't follow along this order, I follow along my original order. So now let's just count up. We have 3 carbons on the left, 8 hydrogens, and 2 oxygens. On the right, 1 carbon, 2 hydrogens, and 3 oxygens. It's the same as last time because we have the same products as last time. Okay, so now let's start making changes. This time, though, we have to fix the C's. Okay, so how do we fix the C's? We're going to put a 3 here. Now this 3, remember, means that I have 3 carbon dioxides. So that will change the number of carbons, but it also changes the number of oxygens. Not to 6, but to 7. Okay, why 7? 3 times 2 plus this guy. All right, next up, what should we fix next? How about the H's? Usually, I honestly just go right down the list. All right, 8 H's on the left, I need 8 H's on the right. I don't want to just put an 8 here, because it's whatever I put here times 2. So what I need to put here is a 4. That will change that to an 8. But look, here's this oxygen again. So I just changed my hydrogens. I have to recount all of the atoms, all of the elements that are in this molecule. So let's come back. We have 3 times 2 oxygens plus another 4 oxygens. So now we are up to 10. Last step, I have to fix my oxygens. I can't do it on this side. I have to do it over here. By the way, here's a hint. If you see an element by itself, tackle that last. But anyway, what do I put out here to make 10 oxygens? Just a 5. So 5 times 2 gets me my 10. So now I have a balanced chemical equation. Thanks for watching.